Okay, next section is over inverse functions. This is section 1.9 in your book, and your quiz over this will be on Monday. We'll start with the looking at them graphically. This is a cubic function right here. Goes through the point 3,5. The inverse of that would be this cubed root right here. So I can take that coordinate and I can just switch it and it becomes 5,3. So the domain of the original function is the range of the inverse and vice versa. You can also see that it's an exact reflection over the diagonal, y equals x. So that's how you look at it graphically. Now as far as notation goes, you may be wondering what this is. Remember that f to the -1 right there? That just means f inverse. It's a symbol that means f inverse. This is not an exponent. So this is not 1 over f. Okay? Numerically, pretty much the same thing. If this is g of x 3, 5, 7, 6, 12, 7, then g inverse would be 5, 3. So you can see the domain and range just flipped. Now, let's move on to algebraically. If you're given a function and you're asked to find the inverse, there's 2 steps that you need to follow. It's very simple. The first step is you want to switch x and y. And the second step is you want to solve for y. So for example, if you're asked to find f inverse, if f of x equals 5 minus 3x over 2. So you're looking at a linear here, so the inverse is definitely going to be a linear. We'll switch x and y, so we get x equals 5 minus 3y over 2. And then solve for y. So multiply both sides by 2. So I get 2x is equal to 5 minus 3y. Subtract the 5. And then divide by -3. And you just found the inverse function. You started with the linear and you ended with the linear. Now let's look at a different function. Let's say that we have a logarithm. G of x equals 3 times the natural log of x minus 2 plus 4. So here again I'll switch x and y, so I get x equals 3 times the natural log of y minus 2 plus 4. I need to isolate the logarithm, so I'll subtract 4. And then divide by 3. Now remember, the base of a natural log is e, so that will come over here and become the base of the exponent. And then you can just add 2. So e to the x minus 4 over 3 plus 2 is your inverse. So for that one, I started with a logarithm and I ended up with an exponential, which are inverses of each other. Now, sometimes you are given 2 functions and you're asked to verify whether or not those 2 functions are inverses of each other. So first of all, you need to know this rule, the definition of an inverse. If you find f of f inverse, that's going to equal x. And then if you find f inverse of f, that'll equal x as well. Whenever you can apply both of those rules and you simplify it down and you get x for both of those, then that tells you that the two functions are inverses of each other. So we're coming back to a composition of functions. So hopefully you haven't forgot what we worked on a couple weeks ago. Now, for example, we'll say that f of x is the rational 5 over x minus 2, and g of x is the rational 5 over x plus 2. So are f and g inverses is the question. So we're going to find f of g first. So I'll take the g function and I'll plug it into the f function. So 5 over, instead of x, I'm going to get 5 over x plus 2. Remember, when you sub that in, you definitely want to use parentheses. Okay. So we have nothing distributing into these parentheses, so we can drop the parentheses. And those guys will cross out. So I'm left with 5 over x. So when you're dividing fractions, it's the same as multiplying by the reciprocal. So these guys will cross out, and we're left with an x. So that one worked. Now let's check g of f. Remember that these are just different notations. You can write it either way. But you're always going to take the inside function and plug it into the outside. So this time I'm going to plug f into g. So 5 over my x is 5 over x minus 2. So there's 5 over x plus 2. So I plugged f into g. Okay, so I've got 5 divided by this fraction. So I'm going to take 5 and I'm going to multiply by the reciprocal. So the 5's will cross out, and I'm left with x minus 2 plus 2. These guys will cross out, and I get x.